Hey everybody, welcome back, and this is video 2 of 3 with the Chapter 7 review/test. Hopefully you have stood by me after my little joke about, the fraction martial arts. You guys are going to all be black belts in partial arts. Oh, really? Really? I don't think it's that bad. Okay, I guess that's, I guess it's only a one-off joke. That's fine, though. But you all should be pretty good after that first video. But you guys think you know all about fractions, but you know what? You don't know the half of it. Thank you. No, good recovery, good recovery. All right. Excellent, excellent. All right, anyway, enough with the jokes. This is not stand-up comedy hour with Mr. Carey. That's a different video entirely. So let's get right into it. We're going to start off with number 7. Bella bought 8/10 of a gallon of water. She drank 6/10 of a gallon of water. So we can probably assume, since I had 8/10, or Bella did, and she drank 6/10, that means you need to subtract. That's right. So let's start off with 8/10. She started off with 8/10. She drank 6/10 of it. How much water is left? Again, easy peasy lemon squeezy. 8 minus 6 is 2. Leave your denominators alone, and you have 2/10. Now, for those of you that want to get extra points, if you're taking my test, you would know that you can reduce 2/10. And if you reduce that fraction, you get an extra point. So let's reduce 2/10. And we're going to divide the top and the bottom by 2. 2 divided by 2 equals 1. 10 divided by 2 equals 5. So you get 1/5, and you get an extra point. And that's fine if you did 2/10. Again, it's correct answer. All right, let's go to number 8. And sorry, I wrote all over my number 8, so I'm going to have to erase this. There we go. All right. In a survey, let's highlight this, 6/10 of the students chose Saturday. 1/10, I'm going to change colors, 1/10 chose Monday as their favorite day of the week. I don't know who chooses Monday, but whatever. I mean, let's not judge on, let's not judge their choices on days of the week. But now, what fraction, right, let's highlight our question here. What fraction shows the students who chose Saturday or Monday, right? Saturday or Monday, also read as Saturday and Monday, as their favorite day. Well, let's shade the model. Well, let's start off with red, because that's Saturday, right? We have 6/10, so start off 1/10, 2/10, 3/10, 4/10, 5/10, 6/10. And then we have our Monday, our one lone Monday guy or gal, and there is 1/10. Now, let's count up our fractions. How many tenths do we have? 1/10, 2/10, 3/10, 4/10, 5/10, 6/10, 7/10. And you can't reduce that. 7/10 is the answer. All right. How are the numerator and the denominator of your answer related to the model, right? So now this is, you don't really have to write any numbers. You just need to, my favorite thing, explain. Tell me, how are the numerator of your answer, numerator and denominator, related to your model? Now, for those, again, I can say it probably another way, and I could say it 10 times that way, but it's not going to make any sense. So it's time for Mr. Carey's patented translations. I'm going to figure out like a cool, sound effect for my translations. Maybe one of these days, but not today. Okay, translation. What does the numerator mean, and what does the denominator mean? I mean, that's all they're asking you, right? How are they related to the model? Just tell me, like, what does that mean? All right, you have a numerator and you have a denominator. What does that mean? And so really, you just need to tell me, for one, then what is the numerator? What is the numerator? Well, it shows how many parts are shaded, or how many students like Saturday, and Monday. I mean, that's all it really is. And this, I think we need to like kind of dial this down a little bit, get this a little smaller. There we go, perfect, because I need another room to write my other one, which is, what about the denominator? I'm going to move it over here, but the denominator, what does the denominator show? The denominator shows the size of the parts, or how many total parts. And in the context of our problem here, how many total students, right? So that, if you explained it like that, like you would totally get, you'd get 100%. Because that's all it is, right? What is the numerator? Students that like Monday or Saturday. What's the denominator? How many total students? Boom. You're in, you're out, you're done, right? Awesome. All right, now number 9, commutative and associative properties. Now here's a quick little review. What is the commutative property? All right, all that means moving the numbers around in a different order. I mean, that is what the commutative property is. That's all it is. You're just moving your numbers around, right? So 2 plus, actually, I can just tell you, or how about I just show you? If only I had like an Apple Pencil where I could show you. So how about 2 plus 3 plus 4? I could easily write that as 4 plus 3 plus 2, or 4 plus 2 plus 3, or 2 plus 4 plus 3, right? They're all the same thing. I'm just switching the order around. What's a good way to think about it? Like, how about all the numbers are a community? It's a community of numbers, so it doesn't matter how you add them up. They just kind of, they all add up to the same, to the same add-in, to the same total. Yeah, I just kind of came up with that. It's not very good. I'll work on it though. All right, so I'm going to erase this. So now a quick review. Let's go into the associative property. Now the associative property is pretty cool as well. And trust me, it's not just me reviewing this. This is actually going to mean something. Here we go. I like the term bundling only because my son uses it with like bundling hair. Isn't like, I just think it's funny. So bundling, or you can even put grouping numbers to make it easier to add. Think whole numbers or friendly numbers, right? If you're just doing addition, friendly numbers 10, 20, 30, 40, 50. If you're doing fractions and you're trying to get your whole numbers, right? So, and I've got kind of a fun way. Like my commutative property didn't go well. Like they're a community of numbers, and it doesn't matter how you switch them around, you can still get the same, the same total. Well, okay. How about associative property? This maybe will go a little better. Think of them, right? And so all the associative property. Let me show you an example, right? So we did 2 plus 3 plus 4. So what's something I want to add together, right? So if I just did like this, 2 plus 3 plus 4, like that would be associative. You could do it another way. You can do 4 plus 2 plus 3. That would be associative and commutative, but this right here at the top, this one, not the one I'm erasing, this little guy right there, that's going to be more your associative property. All right, so think of the associative property, right, as in you are associating, you're bundling, you're associating the different numbers together so it makes it easier for you to add, right? Hence, it's called the associative property. I know, it's not too bad. I just kind of came up with that, but I appreciate you guys on that. So now that we've got a nice little review here, let's go in and let's match the equation, right? So erase, erase, erase. Perfect. Let's do it. All right, 6, and then look at here. We're going to do number 1, 6 tenths plus 4 tenths plus 3 tenths. Now look at, did I change the order of the numbers? I still have 6 plus 4 plus 3. And here I have 6 plus 4 plus 3. So all I've done is change the parentheses, right? Here, this would be kind of weird. 4 tenths plus 3 tenths give me 7 tenths. But this, look at that guy, 10 tenths, which is 1. So I'm associating my numbers in a different way. Hence, it's the associative property. My next one I've got, and let's look at the order here. So the parentheses are kind of in the same, but look, I have 1 plus 3 plus 2. I'm just looking at the whole numbers. Now I have 1 plus 2 plus 3. And look, we shuffled the order of the numbers around. So that is going to be my commutative property. And let's go back here. I have 2 plus 1/10 plus 3. And here I have 2 plus 1/10 plus 3. So I haven't changed the order of them. But look, the parentheses were here. That didn't really make much sense. But now we've shuffled them to, we've grouped them with 1/10 plus 9/10, which makes it easier for me. So I'm associating the numbers that make it easier for me to add together. Hence, that's the associative property. And then last but not least, let's look. When I'm checking the commutative property, I just look at my order. Look at my whole numbers. 3 plus 2 plus 6. So if it's in the same order, we'll be golden. But look, 2 plus 3 plus 6. So I've changed the order around, so that's going to be my commutative property. Excellent. All right, so let's go on to our second page of the video. And we're going to ready, 3, 2, 1, boom, delete. Let's put up our another page here, and this should be page 324, and 5, 4, 3, 2, 1, boom, there it is. Okay, now, this is really cool, right? 10A through 10E is like an easy 5 points. I mean, I mark each one of these as a point. All you're doing is just checking the addition or the subtraction. Is the sum or the difference, are they correct? Well, let's take a look. Is 2 eighths plus 1 eighth 3 eighths? Is 2 plus 1 3? Sure it is. They haven't really messed with anything. They haven't messed with the denominators. 2 plus 1 is 3. Good. What about 4 fifths plus 1 fifth? Does that equal 5 fifths? Sure it does. And now look, 10C, they're going to try and trick you. Is 4 6 plus 1 6? How about this? Is 4 plus 1 5? Yes, it is. But look what they did, right? 6 plus 6 is 12. It is, but when you're adding fractions, don't touch the denominator. Don't even think about it. Leave it alone, right? So that's a big fat no. And then let's go back over here. Is 6 twelfths minus 4 twelfths 2 twelfths? Is 6 minus 4 2? Yes. Did they mess with the denominators? No. So that is a yes. And then look at 10E. Now, many of you, if you were taking this test, you'd probably just, oh yeah, 7 plus 2 is 9, boom. But it's not. You know why? Because of this little guy right there, your subtraction symbol. So 7 ninths minus 2 ninths. Can I subtract 2 ninths from 7 ninths and get a higher number? No. So that's a big fat no. All right. Excellent. Now, let's go over here to number 11. Gina. Gina has 5 2/6 feet of silver ribbon. And she has 2 4/6 of gold ribbon. How much more silver ribbon does Gina have than gold ribbon? How much more? Meaning we're going to use our friend again, Mr. Well, that didn't really work out too well, did it? I was trying to put my pen on there. Here we go. One more time. Mr. Subtraction. We're going to use subtraction again. All right. So all we're doing is subtracting 5 2/6 minus 2 4/6. That's all we're doing. So let's go ahead and let's stop talking about it and let's do it. 5 2/6 minus 2 4/6. Now before we do this, look at these guys right here, right? I can't subtract 4/6 from 2/6. I can't do it. So what I have to do is I have to change this guy into, it's actually a mixed number with an improper fraction. So how do I do that? Remember, I have 5 here, right? 5 wholes. Can we agree that the same thing as 5 wholes, I have 6 6, 6 6, 6 6, 6 6, and 6 6. Would we agree that that is what 5 wholes would look like? Yes. So what we're going to do is we are going to give, as in add, one of these 6 6, and we're going to add it to this, which means we're taking it away from this. So we take away a whole, and that whole goes to 6 6 plus 2 6 should be 8 6. We can leave our 2 and 4/6 alone. And now we just straight up subtract. 8/6 minus 4/6 should still give me 4/6. 4 minus 2 is 2. Now, you can leave your answer like this, 2 and 4/6. If you want that extra point, reduce your fraction. As in, 2 and 4/6, I can divide the top and the bottom of this fraction by 2. 4 divided by 2 is 2. 6 divided by 2 is 3. That will get you an extra point. 2 and 2/3. All right, let's kick on over to number 12. Jill is making a long cape. I don't know why. Yeah, but hey, maybe it's for Halloween. Maybe she just likes capes. Maybe it's for a Harry Potter thing. Who knows? Anyway, let's not judge Jill for making her cape. Let's figure out how she's going to make her cape. So she needs 4 and 1/3 of, you know what? I'm like doing it with green. Why don't I just do it in, it's not like I don't have a blue marker here. 4 and 1/3 of blue fabric for the outside of the cape. And then she needs, what else does she need? She needs, I have a purple here, 3 and 2/3 yard of purple fabric for the lining of the cake. For the cake. Cake is on my mind. So Jill incorrectly subtracted the two mixed numbers to find how much more blue fabric than purple fabric she should buy, blah, 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 right? Okay, but now we need to figure out why is her work incorrect. So it looks like, and I'm going to put a little tip here. This is probably one of my first little tips. And I feel like I do have a sound effect I could do for ideas. So here we go. I'm going to write a little idea, and this is a tip. As soon as I can draw, you'll see what I'm drawing in a minute. There's my, and then there's like this, and it's starting to look like a light bulb, right? And then it goes do, 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 do. So here you go. Here is a tip from Mr. Carey. All right, excellent. Thank you, sound effect man. All right, tip. They're showing you the second way to subtract mixed numbers, right? So this is a tip, right? If you're looking at this, you're like, I don't know what Jill did. It looks good to me. Remember, they are showing you the second way to subtract mixed numbers, as in converting mixed numbers into improper fractions. So that's what they've done here, right? So if this is confusing to you, just look, this is what they're doing. So we have to figure out what she has done. The best way to do this is just kind of convert the fractions yourself. I mean, you can sit there and figure out what Jill did. I would really just, if she's done it incorrect, fine. Let's figure out how we would do it. So let me write this a little bigger. I'm gonna do this just the addition way. So 4 and 1/3. Can we say that 4 and 1/3 is equal to 3/3 plus 3/3 plus 3/3 plus 3/3 plus 1/3? What do you think? Can we agree with that? Sure. And now all we have to do is just add them up. 3, 6, 9, 12, 13. Okay, so this should be 13/3. All right, and I'm going to do my other one, my 3 and 2/3 in red, right? There we go, 3 and 2/3, right? So let's do that. So that's the same as 3/3 plus 3/3 plus 3/3 plus 2/3. Why? Well, because I have my 3, that's my whole number. These are all wholes. That's 1 whole, 2 whole, 3 wholes, and my 2/3. And let's add them up. 3, 6, 9, 10, 11. All right, so we have 11/3. So there's my first answer, or my second answer. There's my first answer. Now, look at what Jill has. She has 12/3 minus 9/3. So her fractions are off. And I can look at what she did, right? So it looks like she just stopped, right? So if she got 12/3, so this is 3, 6, 9, 12. So it looks like she used the whole numbers but didn't add the fraction. And let's see if it's the same thing here. 3, 6, 9 Yep, same thing. She only added the whole numbers but didn't add the fraction. All right, so now we need to kind of... oh. Hello. Who's making those sound effects? Certainly not me. Wow. All right. Interesting. Did not need all those sound effects. I appreciate that. And I'm going to write those fractions because we had them up there, right? 13 thirds and 11 thirds, right? So why is Jill's work incorrect? Well, number one, Jill converted the whole numbers to, I don't need it capitalized, numbers to fractions. Actually, what kind of fractions, right? It's my improper fractions. Whole numbers to improper fractions correctly, but she forgot to add the last fraction. In this case, it would have been 1/3 and 2/3. I mean, that's what she did, right? So you say something like that. If you show me your work and you have a little explanation, I'm going to give you full credit. All right? The cool part about part B is, look at this. How much more blue fabric than purple fabric should she buy? Basically, what does that mean? It's just, let's do another translation here. All right, let's make this, right. I don't know how much more she should buy. Why are you asking me? I'm not a fabric guy. You know, I deal only in like wood crafts. But the translation, right? What does that mean? Translation, really, subtract blue minus purple. That's all it's saying, right? How much more should she buy? That's just saying, take your blue fabric, go blue minus purple, get your answer. Now, the cool thing is we don't have to really do anything because, look at this, we've already converted our fractions correctly. That is why I did it at the beginning, right? So now we can just do a straight 13 thirds minus 11 thirds gets us a cool 2/3 of a what? Of a yard. And that's it. I mean, you can say, if it makes you feel better, right, you can go, Jill should buy 2/3 of a yard more blue, right? You can write that. Fine, I'll write it. Jill should buy 2/3 of a yard more blue fabric. I mean, you can write that. If that makes you feel better, go ahead and write that. And guess what, folks? That is the end of video 2. We kind of just breezed right through that. So hopefully this is helpful to you. Video 3, you know, it's going to be great. It's going to be the end of chapter 7, end of adding and subtracting fractions. You should feel a great weight just lifted off your shoulders once we complete this. And I look forward to completing your journey into chapter 7, or finishing chapter 7 and into chapter 8. Until then, this is Mr. Carey signing out, and I will see you later.